cover section 6 again, but this would be part 2 of the video because we are going to now look at equations that are in standard form for graphing. And here again are our steps that we looked at for section 6. So here on step 1, we're going to look at graphing with intercepts because our equations are going to be in standard form. And so we're still going to have to decide if we're going to use a dashed or a solid line. And then we're going to shade the true side of the boundary line, testing an ordered pair in order to do that. So let's go ahead and go on down to those examples, and that would be example number 6 to start with. So this is in standard form because both x and y are over here on the left side of the equation. And so it says 4x minus 8y is less than or equal to 16. So because this is in standard form, again, we need to find the intercepts for the graph. Remember that an intercept is where the graph is going to cross the x-axis or the y-axis, and so we are going to plug in 0 just once for the opposite variable. So if I want the y-intercept, I'm going to plug in 0 for x, and I want the x-intercept, I'm going to plug in 0 for y. So if I was to plug in 0 here, that'd be 8 times 0, that is 0. And so we're just going to be left with 4x equals 16. To find the x-intercept, to get x by itself, we divide both sides by 4. And so the x-intercept would be 4, 16 divided by 4 is 4. The y-intercept, let's plug in 0 for x, so 4 times 0 is 0. We're going to have negative 8y equals 16. Divide both sides by negative 8. Y is going to equal negative 2. Now when I find intercepts, I go ahead and use equal signs. This inequality is going to affect which side we shade, but it's not affecting the intercept itself. So intercepts get placed on the axis. So it says x equals 4, we're going to go to 4 and put a dot. Y equals negative 2, we're going to go to negative 2 and put a dot. And so this is going to be a solid line because it is an equal to. Go ahead and grab our line tool here. Use your ruler, draw through there. And of course, we'd want those technically to be arrows there on the end of our graph. Get that out of the way. Okay. And so now we need to decide which side to shade. And so for shading, right, we're going to plug in the ordered pair 0, 0. So sometimes that is confusing. To find intercepts, you plug in 0, 1 at a time. But now to decide where to shade, we're going to have to plug in both. So again, just like we did in part 1, anything times 0 is 0. And that's why I like this as an ordered pair. So if I work this out, 4 times 0 minus 8 times 0, this whole side is going to turn into 0. And so when I evaluate that, I'm going to say, is 0 less than or equal to 16? Because this whole side turned into 0. And 0 is less than 16. So 0, 0 is true. So then I need to shade this side of the line because that's where 0, 0 was. If it was false, we of course would have shaded the opposite side. Let's look at example number 7. Okay, so on example number 7, we have negative 2x minus 6y is greater than or equal to 6. Again, this is standard form, so we're going to find the intercepts. So I'm going to say negative 2x equals 6. Divide both sides by negative 2. X is negative 3. And then to find the y-intercept, I plug in 0 for x, so that's going to leave me with negative 6y equals 6. Divide both sides by negative 6. Y is going to equal negative 1. With that, then, again, we're going to put the x-intercept on the x-axis, the y-intercept on the y-axis, and we're going to draw, again, a line here. It is going to be solid because it is equal to through both points here. And to decide if where we're going to shade, we are going to test the ordered pair. Grabbed my graph on accident. For shading, Okay, again, I'm going to plug in 0 and 0. And when I do that, -2 times 0 minus 6 times 0, this whole side turns into 0. So now I'm comparing 0. Is it greater than or equal to 6? And 0 is not. So this time, 0, 0 is false. And so we shade the other side. So we have 2 examples left, 3 examples left. Let's go ahead and look at example number 8 here. And on example number 8, we have 2x plus 3y is greater than 12. Something I did notice here, this is just a greater than sign, so when we go to do our line, we're going to want to make sure it's dashed. So let's find our intercepts first. So we're going to have 2x equals 12, and divide both sides by 2, x is going to equal 6. 3y equals 12, divide both sides by 3 to get y by itself, y is going to equal 4. And so we're going to go to the x-axis and put a dot at 6 because that was your x-intercept, y-intercept of positive 4. And again, we want this to be a dashed line. So let's pull that through. And again, we want to now test which side of the line should be shaded. And we're going to test 0, 0. And so 2 times 0 plus 3 times 0, this whole side again turns into 0. So for the shading, I am using the ordered pair 0, 0. And I'm saying is 0 greater than 12. And that would be false, that 0 is greater than 12. So this down here is false, which means we are going to shade the other side. So with 2 examples left, I would like you to hit pause and try the last 2 examples on your own and then see how you do. And when you're done, hit play. Okay, here's the results for example number 9. Again, we are in standard form, so we're going to find intercepts. A little bit difference on a couple of these here. -3x equals 3. For our x-intercept, we could divide both sides by -3. X is going to be -1. For the y-intercept, there is no coefficient in front of y, so you're just going to write y equals 3. Remember, it's a 1. If you divided both sides by 1, y would still equal 3. So something not to try to get confused there. On the x-axis of -1, y-axis 3. Again, this does need to be a dashed line because of the less than sign. And then for the shading, plugging in 0, 0, this whole side turns into 0, 3 times 0 plus 0. So is 0 less than 3 determined for the shading? And 0 is smaller than 3. And so 0, 0 is here on the graph, and it is true. So I'm going to shade this whole entire side. Looking at example number 10 to find those intercepts, again, because it's in standard form. 12x equals 24, divide both sides by 12x equals 2, and 4y equals 24, divide both sides by 4, y equals 6. So we're going to go from 6 on the y-axis to 2 on the x-axis. This time I do get a solid line. And the shading would be 12 times 0 plus 4 times 0. So we're saying is 0 greater than 24? And that is false. So we need to shade the other side.